Alrighty, so I have chosen to do problem 5.3 for you guys. And chapter 5 deals with the work energy theorem and the conservation of mechanical energy and all the other conservation laws. So with this in mind, let's look at the problem, which is a small cube of mass m sliding down a circular path of radius r. Let's go ahead and draw this. Like this, and we have a block. This is big M, this is little m, and it's on a frictionless table. I think everything is frictionless, yeah. The blocks are initially at rest, and then little m starts from the top of the block, as shown, and then there's this radius here of r, with the rest of the circle being like this, and that is definitely a circle. So we want to find v of the tiny block when it's falling off the block. So we want to find it when it's here. And just to clarify everything, we're just gonna call this velocity of the tiny block at the final, we'll call it just tiny vf, and the velocity of the big block final, just big F, big V final. So now we know I guess just to start off, the conservation laws. So for momentum, Pf is equal to P initial, that is an I promise. And then we know for the conservation of mechanical energy, Ki plus Ui is equal to K final plus U final. So we know in our initial state, we have Ki is equal to 0 because they are at rest, and Ui is equal to just the tiny block mass times gravity, and then we'll do height here for this block. And then, so that would give us the total energy, initial energy, equal to Ki plus Ui, which equals 0 plus mgh, so we're just left with mgh. And then for our final state, we want to look at the same thing. So K final is 1/2 m little f final squared plus 1/2 of the big M, big V final squared. And then U of f would be, I believe, mg of, and then this is moving, so it would be h minus r. So that would leave us our final energy here to be 1/2 little m little vf squared plus 1/2 big M big V squared, and then plus mg of h minus r. I should also mention that this up here, Pi, would be, I believe, 0, and then the P final would be, let's see, m V final, tiny v, minus big V final. So, we want to apply our laws now. So, we know E final is equal to E initial, the total energies. So, using this, we would get 1/2 tiny v, tiny m squared plus 1/2 big M, big V final squared plus mg h minus r is equal to mgh. So, then with the momentum, we know tiny mvf is equal to, or would be equal to, big M vf. So, with that in mind, we can start doing some math. Let me just move this up just a little. So, now we want to solve for our tiny vf here. So, from this, we can discern that big V final is equal to tiny m, tiny v over big M. We can apply that to this right here, and we would get 1/2 mv squared plus 1/2 mv squared minus mgr equal to 0. And then we can do 1/2 mv squared plus 1/2 big M, and then this we know, if we square this, would be tiny m vf over big M squared minus mgr equal to 0. And then from there, we can times everything by 2 to get rid of the halves. So you would get m v squared plus m of tiny m v final over m squared minus mgr. It's still equal to 0. So, and then I would say divide by m, tiny m. So we get v squared plus big M. Actually, first let's expand this, I believe. So I guess we can do both at the same time. V squared plus, I believe it would come out to be m v squared over m minus 2gr, I believe. Let me think about that for a second. Next that would square. Yeah, I think that's right. So then from here we can toss over the 2gr to the other side and then pull out the v squares. So you get v squared of 1 plus, no, wait, I'm sorry, yeah. You would want to toss over that 2gr still, but you would want to multiply by m to get rid of this. So you would get m v squared, capital M, plus v squared of tiny m v squared equal to 2gr times m. And then you want to pull out the v squared, and then you want to multiply by m plus m is equal to 2grm. And then we just want to solve for v squared. So v is equal to 2grm over m plus m, and then so v is equal to the square root of 2grm over m plus m, and that can be simplified further to m is equal to the square root of 2gr times m over big M plus m. And there we have it.